Okay, lesson 5.2 is all about solving absolute value functions. First thing that we're going to do is we're going to look at the graphs of the parent functions to figure out why we get some of the solutions that we get. So in this first section, problem number 1, we're first going to graph y equals the absolute value of x. And we're actually going to graph that on every single graph. We know that that has a vertex where? Where does that absolute value function have its vertex? 0, 0, right? The vertex is 0, 0. 0 would make that inside the absolute value 0, and there's nothing being added. So that has a vertex of 0, 0. What are the slopes? 1 and negative 1. Okay, so I just go up 1, right 1 all the way, and then up 1, left 1, and let's draw the absolute value graph. Okay, so there's all the possible points that would solve the equation y equals the absolute value of x. Okay, so there's my graph. Now, we're trying to find what values of x give me a y value of 4. Well, y equals 4 is right here. So there's one place where the y value is 4, and here's another place where the y value is 4. So you can see we do get two solutions. Okay, so my two solutions for this are x equals 4 and negative 4. That's one way you could write it. What's another way I told you you could write it? Right? Layla did her little air writing. Okay. Another way you could write that is x equals plus or minus 4. I have to show you another way that it can be written because sometimes that's the way they write it on like a standardized multiple choice test. So eventually you're going to be taking the PSAT, the SAT, the ACT, something like that. And they write answers like this in something called set notation. So they actually put those answers in a little set of brackets like that. Okay? You get to choose the way you want to do it. If you like making fancy little brackets, do it this way. If you like taking a shortcut and saying plus or minus, do it that way. If you just want to list them each separately, do it that way. Okay, so what I want you to notice here is this is a positive number. And when the absolute value is all by itself and it equals the positive number, how many solutions did we get? How many? I didn't get all real numbers. How many solutions did I get for x? 2. So positive number equals 2 solutions. All right, let's look at the next one. We're going to graph that parent function again. The vertex is at 0, 0. And we go up 1, left 1, up 1, left 1. And there's that side. And then we go up 1, right 1, up 1, right 1 on the other side. There's that side. And this time, we're looking for the places on that graph where the y value is negative 5. Well, negative 5's down here. Are there any points on that absolute value graph where the y value is negative 5? Are there? No. Okay. So when this is a negative number, how many solutions do we get? None. We get no solution. Okay, so we're going to write that there, and then we're going to also write that down here. So that doesn't, I don't like the way that looks. I'm going to separate those. Okay, so that's one way of writing it. On a standardized tests, they might not have the words no solution written down. They might write it in this kind of notation, which means they would have that symbol inside that curly bracket. Does that mean 0? No, that's why when some of you at the beginning of the year, I walked around and told some of you who wrote your 0 like that you're not allowed to write your 0 like that, because in math that means empty set. There's nothing in there. But instead of leaving it empty, they put that symbol in there. Okay? So if there's no solution, when you take a standardized test, that's how they might communicate it to you. Okay? All right. Now let's do it one more time. We're going to graph the parent function. Okay, so vertex is at 0, 0, slope is 1 and negative 1. Okay, and this time we're asking for all the x values that make y 0. Well, y is 0 right here. 1 point, and that happens at x equals 0. There's only one x value that pops 0 out. So the other way of writing that in set notation is like that. Okay? So when this is 0, how many solutions will you get when you're solving an absolute value equation? 1. Okay? 1 solution. We're going to start solving really complicated absolute value equations. Knowing if you get 1, 2, or no solutions is super critical because the way you solve them is very different for each of those. Okay, so let's talk about the steps for solving an absolute value equation. The first step is you have to isolate the absolute value. What do I mean by isolate? What does that mean? We've isolated before in this class. What do we do when we isolate something?
Get rid of it.
We don't get rid of it, we get rid of everything else, right? Okay, we make sure it is all by itself on one side of the equal sign with a number on the other side. So that's your goal. Get the absolute value symbol with whatever's inside there. We don't know. It could be anything. All by itself and a number on the other side. Nothing being added to the absolute value symbol, nothing being multiplied by the absolute value symbol. Absolute value symbol all alone. And we'll see how to do that in a minute. After you've done that, I really want to put a middle step in here. You have to pause a minute. You have to pause and look at what you have for your number. Because that's when you're going to make the decision, 1 solution, 2 solution, or no solution. People that don't pause miss the fact that there's no solution. They quickly keep on going and keep solving. Okay, so pause there and say, okay, 1 solution, 2 solution, or no solution. Okay, so we'll be pausing a lot. All right. When you pause, that's what you're doing. You determine how many possible solutions there are. How many? So you look and you say, okay, absolute values all alone with stuff inside it. Okay, there'll be stuff inside the absolute value, but it's all alone and there's some number C over here. If C is positive, you know you're going to have how many solutions? 2. Just like up here. C was positive and I had 2 solutions. If you isolate the absolute value, you have it all by itself with stuff inside, but nothing with it on that side of the equal sign. And you have a number over here, and that number is negative. How many solutions do you have? 0, none, no solutions. We can never take the absolute value of something and end up with a negative number. Okay, the other possibility is that you got that absolute value all by itself and it was equal to 0. How many solutions will that give you? 1. Okay, so that's critical, that you pause literally for 5 seconds and ask yourself the question, okay, how many solutions do I have to have when I'm done? Okay, so let's look at number 1. Is the absolute value all alone? No, that's 4 is being added to it. So I got to move that 4. How do I move that 4 to the other side? Brian? Subtract the 4, just like we did first semester when we were solving. The absolute value symbols are still there. They do not go away. And on the other side, I get 6. 10 minus 4 is 6. Now I'm going to pause. How many solutions am I going to get? Ryan? 2. We're going to get 2 because we know that either when I solve 2x plus 1, I get a 6 inside of there, or when I solve 2x plus 1, I got a negative 6 inside there. If you end up with a negative 6 inside this absolute value symbol, what pops out? Positive 6. Okay, so now at this point, since I need 2 solutions, I now break this out into 2 equations. So either what's inside of here was equal to 6, okay, because if 2x plus 6 is equal to 6, then when I take the absolute value of it, I get 6. Or maybe 2x plus 1 was equal to negative 6. Because if 2x plus 1 is the same thing as negative 6, the absolute value of negative 6 is 6. Now notice what I did there. I wrote 2 separate equations and the absolute value signs went away, right? Because either the middle thing here is equal to 6 or this middle thing is, oops, I said negative 6, but I never wrote it. Negative 6 there. Sorry about that. That must have been confusing. Okay, now I have 2 separate equations. I solve those 2 equations, and that's how I get my 2 solutions. So this is super easy to solve. Subtract 1 from both sides. Then divide both sides by 2. So one of my solutions is 5/2. You can leave it like 5/2, or you can write it as 2.5. Can I write it as 2 1/2? No, no mixed numbers. That's elementary school. Okay, so 2.5. And then this one I solve, first thing I do is I subtract 1, and I get 2x equals negative 7. And then I divide by 2, and so x equals negative 7/2. That's my favorite answer, but if you want to change it to negative 3.5, you can. Okay? So it's fine if you leave your answers written like that, or you may see set notation with the answers written like that. All right, any questions so far? Why did I break it up into 2 separate equations? Because I knew I needed 2 solutions. And those 2 solutions come from when the inside equals 6 or when the inside equals negative 6. All right, let's look at number 2. First thing I'm going to do is I'm going to get the absolute value all by itself. So I subtract 4 from both sides, and what do I get? The absolute value of 2x plus 1, make sure it's still an absolute value, equals what? Negative 1, right? If I subtract 4 from both sides, I get negative 1. Now I'm going to pause and I'm going to ask myself, okay, how many solutions? 1, 2, or none? None. I'm done. I don't have to do any more work except write no solution. This is negative. Therefore, no solution. Students who do not pause and ask themselves that question often keep going. Okay, they don't take the time to think, okay, oh, negative number, I'm done. Okay, let's turn over in the back. All right, absolute value is not alone, so again, I have to get it alone. So I subtract 4 from both sides, and when I subtract 4, I get 0. How many solutions? 1. Because the inside of this has to equal 0. It can't equal 0 and negative 0. There's no such thing as negative 0. Okay? So the only solution, so one solution equals one equation. And that equation is 2x plus 1 equals 0. And so solve that, subtract 1 from both sides, and then divide by 2, x equals negative 1/2. Okay. By the way, you can check all of these, just like, first semester, you could always check your answer by putting that back in here and making sure you do get 0 inside there. 2 times negative 1/2 is negative 1, negative 1 plus 1 is 0. Okay? Okay, go ahead and do number 4. Do number 4. First thing you did was what? Subtract 2 from both sides. The next thing you did was pause and ask yourself, how many solutions? 2. 2 solutions. So how many equations? 2. What's one of the equations? 3x equals 6. What's the other equation? 3x equals negative 6. Perfect. So x equals 2 is one of my solutions. X equals negative 2 is the other one. All right, number 5, you're starting to get a little bit more complicated. You may be tempted to distribute that 3. You are not allowed to distribute through absolute value symbols. The only thing you're allowed to distribute through is parentheses. Okay? So no distribution with absolute value signs. Think of those as walls. Those are walls, and you cannot get through them with another number. Okay? So no distribution with an absolute value sign. So we still have to get the absolute value alone, though. So the first thing that you're going to get rid of, we always get rid of the addition and subtraction first. Okay, so I'm going to add 2 to both sides. So 3 times 4x minus 5. If I add 2 to both sides, I get 21. The absolute value is still not alone. How do I get rid of that 3? Yes?
Subtract it.
No?
Divide.
Divide it. Yeah, right now it's being multiplied by the absolute value. The way you undo multiplication is you divide. Okay? So the 3's cancel over here, and I get the absolute value of 4x minus 5 equals 7. All right, so now you pause. 1, 2, or no solution? 2, right, Nate? And so what's one of my equations? 4x minus 5 equals 7. And my other equation is 4x minus 5 equals negative 7. Okay, go ahead and solve those real quick. See what you get. That's the easy part. X equals 12, so x equals 3 is one of them. And then 4x equals negative 2, so x equals negative 1/2 is the other one. Okay. All right. Go ahead and do number 6. Do number 6. Okay, and remember, let's see, no, somebody left the room already. My pass is gone. Sure. All right, what'd you get for number 6?
No solution.
Yeah, no solution. Good on you. Last class period, everybody had solutions, because what did they forget to do?
Check.
Pause. Okay, they just kept going. So negative 5x equals 10, because you subtract 2 from both sides first. And then, go ahead, John, you divide by negative 5, and you get that. And when you get that negative number and you pause, you say, oh, no solution. Okay, let's do number 7 together, because number 7's just a little bit different. First thing I'm going to do is add 3. And I get 0. I don't have it all by itself yet, though. Okay? How do I get rid of that 3/5? Brian? Yeah, multiply by 5 over 3. Multiply by the reciprocal of that fraction. Or you could do it in 2 steps. Multiply by 5 first, and then divide by 3. It's whatever your preference is. My preference is always multiply both sides by the reciprocal of that fraction. Okay? And what happens there is those two things cancel out, and you get 2x minus 4. Of course, it's still going to be equal to 0. Okay? And so now you know you're going to get one solution from one equation, and that one equation is 2x minus 4 equals 0. So 2x equals 4, so x equals 2. All right, go ahead and do number 8 and see what you get for number 8. Okay, when you got the absolute value all by itself, you should have got that it was equal to 10.
Yep.
Okay. You move the 3 to the other side. And so you get 6, and then you multiply by 5/3, and 6 times 5/3 is 10. So how many solutions? 2. So 2x minus 4 equals 10. Do you have a question? Okay, just stretching. Okay. And 2x minus 4 equals negative 10. Okay? And when you solve this one, 2x equals 14. So x equals 7 was one of your solutions. And on the other side, 2x equals negative 6. So x equals negative 3 was your other one. Okay? All right. What do you think? Got it? Okay, so you have 15 minutes. I think that some of you can probably finish the homework, and the rest of you can make a big dent in it so you don't have too much to do. Or somebody's out of the room on this. I have this guy in person. He may come back here next. Go ahead, Rex.